In this video, we present the design and control optimization for a nature-inspired UAV via collaborative co-evolution. Here is a summary of the design variables to be optimized. Control is achieved by actuating the flaps in a cyclic manner. Cyclic motion is generated via a central pattern generator, turning higher-level locomotion commands into low-level oscillatory actuator commands. An additional pacemaker oscillator ensures better synchronization, making our control less susceptible to drift. Position control is achieved via cascaded P and PID controllers. Altitude control acts directly on the motor commands. Here is a summary of the design and control variables to be optimized. We apply collaborative co-evolution, a problem decomposition technique in the optimization routine. Visualizing simulation data, we can see the performance of the population increase as the optimization progresses. The set of parameters that give the highest fitness value is chosen as the final result. In this test, the UAV is tasked to hold position. Configurations with optimized control parameters outperform the baseline parameters. Configurations with optimized design parameters consume less power during flight. In this test, the desired position is updated every 5 seconds, looping between 4 different waypoints. Similar to the previous test, Configuration 1 performs the best in terms of control performance and flight efficiency.